Hello students and welcome to IP Study Lecture videos. In this video, we are going to cover the second chapter of grade 6 and the name of the chapter is Lines and Angles. Students, first of all, let us see what are the different topics we are going to cover under this chapter. So the different topics will be points, line segment, lines, rays, how to measure a line segment, how to compare two line segments, and then we'll see what is an angle, how angle is formed and what are the different kinds of angle, how to measure angles, etc. So without wasting our time, let's start with the first topic, and the topic is point. So point is used to represent position of an object. Okay, it is drawn like a dot like this, and we use a capital letter to represent a point. Okay, it can be A, it can be X, yes, and it has no length or breadth, it has no dimension, we say zero dimension, yes. Now next is line. So a line is a collection of points. When many points come together, they make up a line which can be extended in both directions. These two arrows represent that this line can be extended in any direction like this, or stretched in any direction, that is either leftward or rightward, yes. So the arrow show that the line goes on endlessly in both directions in this figure. Okay, now let's see what are the different properties of lines. So property number 1 says, take a point O on a sheet of paper and draw as many lines as possible. It means if we have a single point like this, we can pass many or infinite lines through this point. Like this can be one of the line that is passing through this point, or this can be a line which is passing through this point. Oh yes, so we have many lines that can pass through a single point. If we have 2 points, then a single line can only pass. There will be no other line other than the line that we have drawn that will be passing through these 2 points A and B. So if there is a single point, then multiple or infinite lines can pass through it. But if there is 2 points, then a single line, a unique line will pass through those 2 points. Okay. Property 3. Let PQ be a line, mark point ABC on the line PQ, observe how many points can you mark on the line PQ. So a line is made up of infinite points, so we can mark infinite points on a line, yes. Now lines, a pair of lines can be classified in 2 ways. Either it will be intersecting or parallel. So if a line is intersecting or tends to intersect, it means let's suppose 2 lines are like this, and if we extend them further and if they meet at any point that is common to them, then the line is called intersecting line. So intersecting lines are lines that intersect each other, whereas parallel lines are lines which do not intersect each other. Here are some real life examples from which we can understand how intersecting lines looks like and how parallel lines look like. Yes, so parallels are like this, they do not intersect, they just go parallel to each other. Yes, so we found these lines in railway tracks or ladder. Yes, they don't meet at any single point. Yes, they just go parallelly to each other. Yes, now if you draw a cross, it means it is an intersecting line. So next is ray. So it is quite similar to line, but it has a fixed point. It means it has a starting point like this, which is represented using a dot. We can write it as O, and there is an ray, or we can say the part of line which can extendly go in one direction like this. So we can stretch it in one direction. In case of line, we can stretch it in any direction, either leftward or rightward. But in ray, there will be only one direction from which it can be extended, the other will be fixed. Yes, like one arrow that we use to play. Yes, so something when have a point and it can be extended in one direction, that is called ray. Okay, now next is how to name a ray. Yes, so for line we use, if let's suppose there is a line like this, we name them like OA like this, and we give a symbol representing line over it with 2 arrows. Yes, so if there is a ray, let's suppose this is a ray, so to name this ray, if you write OA, then a ray will look like this. It will have a starting point and there will be a side which can be extended further. So let's suppose if the ray looks like this and this is, let's suppose, O and this is A, then in that case if we write OA, then the symbols will be on it will be like this, that is arrow will point O, because here the arrow is toward O, not toward A. So depending upon where the arrow is pointing, we name a ray using that reference. Yes. Now properties of ray, similar to the properties of lines, we have properties of rays, like mark a point A on a sheet of paper and draw a ray like this with initial point as A, and we can have different arrows from a single point like this or this. So there are infinite arrow that would be starting from a single point. Yes. Next, mark point O on a sheet of paper, mark another point P and draw a ray through it. So similar to line, if we take 2 points, a single ray will pass through those 2 points. Yes. Next is line segment. So line segment has 2 endpoints like this. Yes. It doesn't have any side which can be extended further. It has a fixed length. Yes. This is an example of line segment. Yes. Because it cannot be extended further. Yes. So a line segment is a part of line. It is a part of line. If some part of the line is taken, it is a line segment which cannot be extended further geometrically. Yes, it has a definite length but no breadth or thickness. It is a length. It means we can measure the distance or the length of the line segment that we have. Yes. Now, to name a line segment, we use, let's suppose if we have line segment AB like this, then we can name it like AB and then a line segment symbol over it, where we'll not put any arrow in either side of the line segment over it. Yes. Now, moving to the next, comparing line segment, how we can compare two line segments. So there are 3 methods that we'll see. One is observation. So suppose if we have a line segment like this 1 and other is 2, on observation we can find out that this line is bigger than this line, but sometimes they can be very closer to each other like this. Now to identify which is bigger, it is very difficult to observe and find out the answer. So we use tracing, where we trace AB first and we put it on the second line segment CD, and if it is fit onto it, it is equal in length. If it becomes slightly less than the CD, then we have CD as the bigger length, and if it crosses the CD, then it will be the bigger line segment that will be seen as AB. Yes. To compare AB and CD, we use tracing paper, trace CD and place traced segment on AB. Yes. So either we can trace AB or either we can trace CD. If we trace AB, then we have to put the traced part on the CD. Yes. The method depends upon the accuracy in tracing. So we have to be very careful while tracing a line segment and then putting it over the other line segment to compare those. Yes. Now, but this can be quite, we can say that this can be quite complex and can occur error while comparing. So there is a third method which is called by using a divider. So in our geometry boxes we have many instruments, out of which one is divider, which looks like a compass. It doesn't have any holding place where the pencils can be put on, but it looks like this. And to compare two line segment, what we can do is we can keep the divider on the first and open it like this. Let's suppose if we have a line segment and a divider is like this. Now if we keep this divider on the second line, and if divider looks like this, then there is some part which is left, it means this line segment is greater than the first one. But if it crosses the first line segment, if the part of the divider crosses the second line segment, then it means that the first line segment was bigger than the second. Yes. So this is what the 3 cases, one is equal, one is the line segment PQ is smaller than MN, and then there where it will be greater than MN. Yes. Now moving to the next point, limitation of these methods. So we have seen 3 methods, and we know that these are very difficult and very tedious to do this, and might be a case where errors can occur. So we use a special method which we'll see in this topic, which is measuring line segment using ruler or using a divider. Yes, so we have already seen how to measure using divider, so we'll focus on the method by using a ruler. Yes, so in a standard ruler, either if it is a short, it will be from 0 centimeter to 15 centimeter marked on it, and if it is a long ruler, then it will be 0 to 30 centimeter marked, which we use in our daily practices. Yes, so in order to measure a line segment, we keep this reference point where 0 is written, and we see how the scale, it is called ruler or scale, how the ruler places to the second point of this line segment, and this represents the number 7. It means this line segment is of 7 centimeter. Yes, so rulers are kept on the 0 marked is kept on the one side, and we observe that what is the value on which the right side of the line segment comes on. So if it is 7, then the line segment is of 7 centimeter. If it is 10, then the line segment is of 10 centimeter. So for divider, we have already understood that how to measure using divider by keeping on the first line segment and then checking the second line segment if it is bigger or smaller. But now instead of measuring that, we can use ruler. How? Let's suppose if we have a divider, and if we keep the divider over PQ, now we can measure this length by keeping the divider with the scale, and we can see how the left part of this divider and right part of the divider set apart to each other with the reference point as 0 centimeter. So it will give us the value of the line segment that we have, like PQ, and then we can do the same thing with the, or same step with the second line segment, and we can observe the values and compare those two line segments. So it will make the task easier. By combining a divider and a ruler, it will be more easier to find out the length which is bigger and which is smaller. Yes. Now moving to angles. What is angle? So student, we know if we go from one place to other place, we measure it using distance, that how much distance we have traveled. But if something is kept like that, and if it is rotated with this reference point like this, then this measurement of how much the thing is rotated is called angle. So angle is quite similar to distance, but angle measures the value of rotation that one has done with the fixed axis. So this is a, let's suppose this is a line and it is a fixed axis, and if you rotate like this, then the measurement of rotation, that how much it is rotated, is the value of angle. And as we have units for measurement, like for money we have rupees, for distance we have kilometer, meter, centimeter, for weights we have units. Similarly, to measure angles we have unit which is degree or radian, but in our class we will use degree only. Okay, so find out how radian is related to degree and see how they relate to each other. Yes, so how angle is formed? So it can be represented that when two rays meet at a single point, an angle is formed. But it can be also understood that this ray has been rotated with angle. Let's suppose if this has a value of x, then this is rotated x degree, where now it lies at OB. So this is the second way of saying this angle. Yes. Now next is how to name an angle. So there are multiple ways by which we can name angle. Let's suppose if an angle which has AOB points on it, then we can name the angle as either AOB or BOA. The vertex, the part of this angle is called vertex. This is called vertex, this is called arm, and this is the second arm. So we have to keep the vertex between the two naming, like A and B. So either we can name it as AOB or BOA. Now let's suppose sometimes while calculating, writing this long name will be tedious and time taking. So instead we can use a number like 1. Let's suppose if we have two angles, so I can name it as 1 or 2 depending upon the requirement. Yes, so this is the first way, either using a letter like AOB, or either naming using angle 1 like this using numbers. Yes, all variable, like we can name this angle as x degree. So if you write x degree, it means it is referring to this angle. So there are multiple ways of writing angles. So but the standard one is writing with 3 letters like A O B, B O C, C A D or P O Q, keeping the point of vertex at the center and using the other 2 at left and right. Yes. Now there are ways how we can name it, and as I have told you that we can consider it as an initial point for the ray, and now it has moved like this, and the angle, that is the measurement of rotation, is calculated using the value of angle, that is, let's suppose x degree, and the rotation will be s degree. Yes. Now interior and exterior of an angle. So when an angle is formed, it forms 2 parts. One is the exterior part of the angle, one is the interior part of the angle. So till this we can consider this as an interior angle or interior part of the angle. Yes. So outside this we have exterior part of the angle. So if a point lies inside the angle, we say that it lies in the interior part of the angle, and if it lies outside the angle, we say that it lies in the exterior part of the angle. And if any point lies on the angle itself, then in that case what we can say is the point lies on the angle itself. Yes. Now next topic is, before moving to the next topic, let me solve one question for you. Okay, so for each of the following figure, name the angle in 2 different ways and also name its vertex. So we can identify the vertex easily. For this it will be L, for this it will be Q, for this it will be O, for this it will be A. Yes. Now for naming we can use either angle, this is a symbol of angle. Yes. So if we use angle KLM or MLK, yes, so give the symbol of angle and then write it using the method where we keep the vertex at the center and we use 2 more points on the left and right side of the vertex. Yes. Measurement of an angle, how to measure an angle and its type. Yes. So depending upon the rotation, different angle has different values, and we can classify different angles based on their values. So we have different angles like right angles. So if the rotation of a ray looks like this, where they are perpendicular, that is, it was horizontal and now it is vertical, then the angle formed has a value of 90 degree and it is called right angle. Now if there is a ray and it rotates and it becomes the opposite or the mirror image of it like this, then the rotation is 180 degree and it is called straight angle. And if a ray rotates and comes back to its original position like this, then this is called a complete revolution or a complete rotation, and the angle formed is called complete angle, which has a value of 360 degree. Straight angle has a value of 180 degree. Right angle has a value of 90 degree, as I have told you earlier. Now next is zero angle. So if there is no rotation of a ray, then the angle formed is zero angle. It is quite simpler. Yes. Now there are various examples on it. You can just go through it and understand how the angles and rotation relate to each other. Now different types of angles. One is the types that we have already seen is based on a certain value. Now there is a range based categorization of angles. So for acute angle, if the angle lies between 0 to 90, greater than 0 but less than 90, then the angle is called acute angle, and it will be always on the right of the right angle that we have. Yes, like this or this. Yes. Now obtuse angle, any angle which lies between 90 and 180, that is greater than 90 degree but less than 180 degree, then it is called obtuse angle, like 135 degree. It will look like this. Yes, greater than 90 degree but less than 180 degree. Yes. Next is reflex angle, any angle between if you say it is greater than 180 but less than 360 degree, then the angle is called reflex angle. Yes, it looks like this. Let's suppose there was a ray over here and is rotated and comes to this position like this, then this is a reflex angle. Clear? Now there are many revolution based questions. So let's suppose if we revolve around a circle like this and comes to our starting point, then the complete rotation is 360 degree, and if we rotate only this part, then this is the 1/4 part of a complete rotation. So 1/4 of a 360-degree rotation will be 90 degree. Similarly, there are various questions based on rotation. So you can use this concept that how much one is rotated and you can find out the value. Let's suppose I say 1/6 of a rotation, then we have to find 1/6 of 360 degree, which will give us 60 degree. It means the person has rotated 60 degree from its original position like this. Okay. Now next topic is measuring a given angle with the help of protractor. So in order to measure an angle, we have an instrument which is a protractor, and it has some component like outer scale for measuring angles which are aligned in the right side of the ray. Like here we have to use the outer values to see how much it is rotated or what is the value of the angle. In case where the angle has to be measured on the left side of the ray like this, then we use the inner scale that we have. Yes. Now one is center, which is aligned with the vertex while measuring, and other is baseline, which is aligned with the ray while measuring the angle. So we use this protractor to measure angles. So let's suppose this is an angle, and if we keep a protractor over here, now this center point aligned with this F, and now this will show how much the inner scale, because it is on the left side, so the inner scale will be used, and we'll see that this measures for 50 degree around. Yes, so the value of this angle is 50 degree. Similarly, you have to keep the protractor over the angle, and you have to measure how much it has been rotated. Yes. Now if it lies on the right side of our body, let's suppose like this, then we use the outer scale to see how much the angle is formed or how much the angle has been rotated. Yes. Now here we have different component explained again, that is inner scale and outer scale. So as I have told you, left side or right side of a angle, instead you can understand it as an anti-clockwise direction. And what is anti-clockwise direction and what is clockwise direction? So if we have a ray like this, and if it rotates in this direction, so it is anti-clock, because clock rotates in this direction. So if something is rotated in opposite of that, it is called anti-clock. So when an angle is rotated in anti-clockwise direction, we use the inside angle. Yes, inside values of the protractor. And if an angle is rotated in clockwise direction, let's suppose like this, then we use the outer scale. So the inner scale generally follows an anti-clockwise direction, center to outer, while the outer scale follow a clockwise direction. The same thing that I have told you earlier. Yes. Now lines can be perpendicular, where if a line is crossing each other or intersecting each other and the angle formed between the two lines is 90 degree, then we call it as perpendicular lines. Yes, perpendicular to each other. Now next is drawing a given angle with the help of protractor. So similar to measuring an angle using protractor, we can use the same protractor to draw an angle also. Yes. So how we can do it? So if we want to draw an angle of 60 degree, what we can do is we can draw a line segment first of any required length, and after placing it, we can see where 60 degree lies. So if we are measuring in the anti-clockwise direction that I have already told you, then this is 60 degree. So I have to draw a line like this, passing through 60 degree until I want it to be. Yes. Now this angle will be measuring 60 degree. Clear? So this is what here it is telling us, that if we want to make an angle of 55 degree, then first of all draw any line segment of the required length, then place this protractor over here where base and the center will align with the vertex and the base with the ray. Yes. Now to draw this, what we will do, we'll see where 55 degree lies. So 55 degrees here. So we draw a line joining this point, and it will give us the value of 55 degree. So it is quite easier and quite similar to how we have measured an angle and how we have drawn an angle. So this is what we have seen. Yes. So students, this is all from my side for this video. I hope you have enjoyed the video and understood the concept very well. Keep practicing, keep learning. See you soon in the next video.